solving this type of questions, or maybe you are giving this guy log of x base 10, right? So this is log of x base 10 is equal to 0.5, and then log of y base 10 is equal to 1.5, and then we have been asked to find x plus y, right? So this is what we are looking for. We want to add these two guys, but look at where they are hiding, right? They are hiding under the log sign, so we need to bring them out. So how do you do that? So the only tool that can help you to do that is to know the way to write from indices to logarithm. So maybe assuming they are siblings, right? They are siblings. So initially we know that in indices, when I say this 2 exponent x is equal to, let's say, something like 1, assuming by assumption. So this is the base. This is what we call the base, right? The bigger number here is the base, and this is what we call the exponent. Is that okay? And this is the answer that you get. Is that okay? So you just need to know this thing. This is base here, and then this is the exponent, and this is the answer. So how can you rewrite this thing in logarithm? So look at something. This is the log here. So what I said earlier on is that log of x base, so this is the base here, is equal to 0.5. So this 0.5 here is the exponent in logarithm. This is the exponent, right? This is raised to the power exponent, and this is the base, and of course this will be the answer, right? So this is the base here, and this is something that you just need to know, right? This is the base, and this is what the exponent. So log of x base 10 is equal to what? Meaning that if I want to rewrite, so let's see how to solve this problem. So I'm having what, log of x base 10 is equal to 0.5. So you just need to rewrite this in. The reason is that they say you should add x plus y. The x plus y, you need to bring the x out, right? We need to know the x and the y before we can add them together. So if I want to rewrite this thing, it means that the base is here, which is 10, base 10, exponent what, 0.5, so 0.5 here, and then the answer is equal to what, x, right? This is the only tool that you need to solve this type of problem. You need to know how to rewrite them from indices to what, logarithm. So the base here is the one down here, right? Look at where this guy down here tells it that is just the base, right? So base 10, exponent, this guy here is what, the answer here is what, the exponent. So exponent 0.5 is equal to it. So you can just use your calculator to do this. So that will give me 3.165, right? It's equal to s. So now that we find the s, so the same scenario you can use to get your y. So your y here, maybe I guess you should pause the video and try that, right? So your y here will be what, base up, the base is 10, then exponent of 1.5, and then the answer is equal to y, right? This is the base and this is the exponent. So that's the relationship between logarithm and what, indices. Okay, so the base is what, 10 raised to the power 1.5 is equal to y. So now we know, so by the help of calculator also, maybe, or with the help of that, you can have 31.623 is equal to y. So now we know the y, and then we know the s. So you can just add it too, because that's what they say you should find. They say find, let's look for s plus y. So now we have our x as well as what, our I. Guess what, add it to. So that will be 3.165 plus what, 31.623. So you add it to, you are going to get to 34.79. So this is how simple you solve this type of problem, by just swapping what, between the indices and logarithm. This is just another logarithm question that says that we should find the value of x from this type of equation. So the equation says that x minus 1 log of 4 base 10 is equal to x log 16 base 10. They say you should find the value of x. So now the trick here, where to start, is to make this logarithm, this guy here, goes away, right? Maybe by assumption we are not okay with logarithm, but we know how to deal with numbers and variables. So we want the logarithm here to go away, so that we can be comfortable in solving our problem using what, the numbers and variables. So the main focus here is how to make this guy goes away. Now your first step is to make sure that from this type of equation, whatever you are seeing here, you have to see the same thing here, right? Any logarithm that you are seeing here, you have to see the same thing here. So the trick here is that this is the smallest number, so you can reduce this guy to suit the 4 here, so that it can cancel out. What I mean by that is that, let's say you have a simple equation like this, right? This equation like this. Can you see that if this guy crosses the equal sign here, it will be cancelled? another negative. So let's turn here to be what, a positive, right? So here, so that they can cancel out. Okay, so if this guy comes here, you can see that I'm seeing the same 2 here, the same 2 here. So the 2 can cancel out by saying that this guy will come here. So here I'm having x plus y to be equal to 2 minus 2, right? 2 minus, oh, sorry, maybe let's say plus or 2 minus 2, that should be equal to 0. Let me say that this guy goes away, right? So the idea is that this guy and this guy has to be the same so that they can cancel out. The same scenario we are exploring here, that the logarithm, we did 2 logarithm here has to be the same. Is that okay? So how can we do that? From this 16, I can get 4 out of the 16. That gives me a 4 square. 4 square will give me 16. Okay, so 4 square here will be 16. So I know one of the law of logarithm says that if something is being raised to this exponent here, this guy here can drop down, right? That is one definition you have to know. So this guy here can come down. That is one, just a simple definition that you have to know. Okay, so after splitting the 16 into 2, I have 4 exponent 2, right? 4 exponent 2 here will give me the same 16. The reason is that I want this guy and this guy to be the same so that they can cancel out. Okay, now we are having what? X minus 1 log of 4 base 10 is equal to this 2x here. Obviously that the 2 drops down, the 2 has to drop down. That is one definition for logarithm, right? It says that when something is being raised into the power here, whatever the exponent here must come down. Okay, so that's how I got my 2s log of 4 base 10 here. Obviously that I'm having the same log 4 base 10, the same log 4 base 10, so they can cancel out, right? This guy can cancel, that guy can cancel that. Is that okay? So here I'm having what, my we will be left with x minus of 1 is equal to 2x, right? That is just a very simple scenario. Is that okay? Okay, now let's move on. So with this we can solve this type of problem very simple. So here I'm having what, x minus 1 is equal to 2x, right? So here we can easily solve this. So that is what, this x will go away, tends to be a negative here. So I'm having minus, I will left with minus 1 here is equal to 2x minus of x. So with this x and s, obviously that they are the same, so you just deal with the number. So that's 2 minus 1, that will give me just 1 here. So because of the variable, you have to repeat that variable to be x. So we are having our s to be minus 1. So this is how simple you solve this type of logarithm questions. This is an logarithm questions that says that we should solve this type of equation, right? So 3 log x base 10 plus log 3 base 10 is equal to log 81 base 10. They say you should solve this type of equation. So look at the question. From the question, you are given this and they say you should solve the equation. Anytime they say you should solve the equation, meaning that you should find the missing what, variable, right? So that is what the question means. Here we are not familiar with what, log, this type of this guy here, we are not familiar with that. So the aim here is to omit, so let the log goes away. Then the log can go away by using a certain method. So what are some of the tools that are needed to solve this type of problem here? So one, you need to understand some of the key terms, here, or maybe the tools that you are supposed to use in solving the problem. So let's have a brief discussion of that. That says that log of first person and the second person, they are multiplied, right? AB. So the first person and the second person, they say this guy is just a log, right? Understand that this is just a newborn baby, so you don't know he's being given a name by what, log. So what it does is the most important thing. So here we are having log of what, AB, meaning that log of the first guy multiplied by the second guy. They say it is what, it means that it's the log of the first person plus what, the log of what, the second person. So what this thing means, that log of AB, log of two things when they are multiplied, this is multiplication, right? One log two things when they are multiplying, so we have to split them into 2 by what, addition. So log of AB is equal to log of what, A plus or log of B, right? So for you to remember this thing so easily, obviously this is a multiplication. Look at the sign. That is my assumption. Look at this sign here. The sign here tells you that this is multiply. So when I switch this guy the other way around, so this is what I'm talking about. So let's have, I have a multiplication, right? This is a multiplication. So when I switch the guy the other way around, this will turn to a plus, right? So for just a simple scenario for you to remember that when you are multiplying two things in log, it means addition, right? So for you to understand that, very easy. So the second one is log of what? AB. So log of the first person divided by the second person, it means that log of the first person minus log of the second person. Once again, maybe I can use the division sign here, right? Division sign in between here to remember that if two guys are being divided in logarithm, so what it means is subtraction, right? So subtraction here. And then the third tool that is very important is log of a exponent x, meaning that log of this guy being raised to certain thing, right? The a exponent x means that you should bring this guy down. Is that okay? So you are